All right, in section 6, we're moving on from simple inequalities to compound inequalities. In this particular video, we're going to handle objective 1 of this lesson, which is to be able to solve standard compound inequalities. Now, a compound inequality is simply an inequality containing two inequalities joined by the word and or the word or. Okay, and each part of the inequality has to be solved separately. Whether it contains the word and versus or is extremely important. Let me give you a scenario explaining why. Let's say you are with a friend. The friend asks you to go in the store and to buy them a candy bar and a pack of gum. So you go into the store, you get your purchase, and then you come back out and you give your friend a candy bar only. Did you fulfill your friend's request? The answer is no. By only bringing them one of the items back, you did not, because they had used the word and. Bring me a candy bar and a pack of gum. Now, had their wording changed, had they said bring me a pack of gum or a candy bar, and you came back with just the candy bar, you'd be perfectly fine. You fulfilled their request. Okay? So the and versus the or of a compound inequality really matters. Let's start with ands. These are known as intersections. Okay? A number is a solution to an and compound inequality if and only if it makes both inequalities true. All right, so notice the example, x is less than 3 and x is greater than -1. I would like to represent the solution set for that graphically. That means I need to find all numbers that make both x less than 3 as well as x greater than -1 true. All right, consider them separately. Okay, x is less than 3 graphs to look like this. X is greater than -1, graphs to look like this. Okay. Now, if you think of the green and the blue graphs there as overlapping or intersecting one another, that's going to occur at the numbers from between -1 and +3. Those are all of the numbers that they have in common, and therefore are solutions to this particular inequality. Okay? Now, in addition to being able to write the inequality like this, you could also represent it with the following notation. Okay? So there's two ways that a and compound inequality can be written. The first we saw was with the word and then the other is a slight shorthand version without the word and. Okay? All right. Ors are often referred to as unions. A number is a solution to an or compound inequality if and only if it makes one or both of the inequalities true. So let's consider the solution set to x greater than 3 or x less than -1. Think about them separately. X is greater than 3, solution set looks like this. X is less than -1, looks like this. Okay. For my compound inequality to be true, I just need numbers from one of the solution sets, if not both of them. It could be from one, it could be from the other, or it could be from both. So therefore, my final solution set is just the union of the two. Simply draw both the green and the purple on the same graph. Okay? Now, unfortunately, there is no other way of writing a union where the inequality direction makes sense. You have to write the word or. So this would be the only way of writing this inequality. Must contain the word or. Okay? All right, let's get to an example of solving a compound inequality involving and. All right, notice in this example, it's starting in the other form. I'm going to give you two different ways you can solve this. So the first way would actually be to separate the inequality and put the word and back in. So that would look like this. Okay. Notice 2x plus 7 that was in the middle of the original compound inequality. It gets written twice, and you put that word and in between. All right, go ahead and solve each half separately. Let's subtract 7 from both sides. I do the same thing here. Six is less than 2x. And 2x is less than or equal to 10. Then I'm going to divide both sides by 2. Same thing here. Three is less than x, and x is less than or equal to 5. Okay, so that would be one way of representing your solution. And another way, you could put it back in the form that it started in. You could just say 3 is less than x, which is less than or equal to 5. Okay, either one works. It doesn't matter to me. Graphically, what's that look like? Well, if you graph 3 is less than x, and then you graph x is less than or equal to 5, look for the overlap between the two. You're going to see that your solution would be all the numbers between 3 and 5. Notice I'm including 5, but I'm not including 3. Right? In the second method, you don't have to separate into two different inequalities. Right? Notice back in method 1, both halves solved using the same steps, right? So what you could do instead is you could leave it as it was originally presented and just try to get the variable alone in the middle of the inequality. And in this approach, the rule would be whatever you're doing to the middle, make sure you do it to the left and to the right of the inequality as well. So I'm going to subtract 7 everywhere, middle, left, and right. That's going to take me here. 6 is less than 2x, which is less than or equal to 10. Then I'm going to divide by 2 everywhere. And 3 is less than x, which is less than or equal to 5. Notice I arrive at the same solution, just with a little bit less work. Okay, here's an example of an or compound inequality. No choice but to solve them separately. So let's subtract 3 from both sides over here on the left. X is going to be less than -1. Carry that word or down. And then divide both sides by -1. Notice you're dividing by a negative. That means you have to flip your inequality symbol. All right, now before you circle that as your final answer, make sure graph them both on the same number line and make sure it fits your standard or scenario. X is less than -1. X is greater than or equal to 4. Sure does. All right, pause the video, move on to these two practice problems, and then start the video back up to check your work.